Hello children, welcome to Yamuna's physics classes. Today we have a topic, refraction through a prism of lesson ray optics section 9.6. Now prism is a term which is familiar for you and we are going to discuss how light ray enters a prism and leaves the prism and what happens in between, entering and emerging. Okay, so we have studied already rectangular glass slab where we know that there is no deviation but only lateral displacement that we have seen in earlier videos. You can see the description if you want. So there is no deviation, just parallelly displaced. But here you can see there is deviation and deviates from two surfaces same as the glass slab. In glass slab we have seen the top surface and the bottom surface there is refraction. Similarly here it's a triangular prism. So for the triangle the two refracting faces are there, both gets refracted. So twice here again the beam is bending. So let us go to the detail. Okay. So this is exactly what you have. This is a prism. This is a prism. And in the prism you have two faces. Number one, this is one refracting face, this is another refracting face. This you call the base of the prism, and usually base of the prism is grounded such that no light enters or leaves the base. But here this prism, all the faces are equally good, they are all refracting faces. Clear? This is a normal prism what we use in a lab. So this is the refracting face number 1. This is another refracting face number 2. And this is taken as the base. And light normally enters this face, leaves this face. In between it passes through the prism, through the medium of the glass, and that is the refracted ray. This you call incident ray, the other one emergent ray, emerging out. And while you draw the picture, you are not going to draw this, just you will show only this triangle. This triangle refers to, this is one face, this is another face, this is the base. So as I have drawn, it is drawn A, B, C, just the triangle is shown. For exams and all, you draw just this triangle alone, A, B, C, meaning AB is the incident face, AC is the refracted face and BC is the base. But in text all you write face, but actually you are drawing a line. And when you say normal, you are using normal to this surface. You are drawing a normal to this surface. Again normal to this surface. Okay. But in picture normal is given to this line. Here again normal to this line. Okay. So that's, you have to carefully think, this is not a line, it is a face. Clear? Okay. Now come to the figure. In the figure what you have is the base, incident face, refracted face. So light ray, this is refractive index N1, refractive index N2, again refractive index N1. These two air, this is glass. Now the incident ray is shown by yellow, refracted one by orange and emergent by magenta. Now if there is no prism, the incident ray should have been gone like this. But once you have a prism, two faces results in bending. One here, the orange, and again the orange leaves the prism, again once again bending. So finally this yellow line or yellow direction of the incident ray is subjected to two bending. One here, the other one here. So this is the finally emerged ray. So emerged ray in this direction, incident ray in this direction. The angle between the two is known as angle of deviation. Angle of deviation. And it is denoted by the small letter delta. But you are not going to draw this figure. This is the figure what you are going to draw. So in this I have taken just the triangle ABC, and this angle between the two refracting faces is known as angle of the prism. So here again two refracting faces, say AB, AC, and this is the angle of the prism A. Now the ray is denoted as PQ incident ray, QR refracted ray, RS emergent ray. Clear? Now at the point Q you have a normal, and that is denoted by N. Here again at the point R you have the normal. The two normals intersect at the point N. Clear? Now this is the angle of incidence, meaning angle between the normal at the point of incidence and the incident ray, that is I. At the point Q, the angle of refraction is R1. Now, why R1? It will be less than I. Why? It is going from rarer to denser. At the time, bending towards the normal. Actually, this is the direction, but it is getting bent towards the normal. Now, same thing carried on to this point R. No bending, nothing, because it is passing through the medium N2. Same medium, no bending. Once it reaches R, again it goes from denser to rarer, N2 to N1. So what happens? This is R2. It gets deviated away from the normal because denser to rarer. So this was the direction, but it gets deviated away from the normal. So E will be much greater than R2. Here the angle of incidence is taken as R2. Make sure. Note, angle of denser medium is taken as R1 and R2. Denser medium angles are taken by the letter R. Then of the medium, rarer medium, it is taken as I and E. Instead of I1 and I2, we will write I and E. I for incidence, E for emergence. Clear? Now, one more thing. As you change the as you change the angle of incidence means angle between incident ray and the normal. You move from this side to slowly, so that I goes on slowly increasing. So what happens? This is the usual case. So the refracted ray slightly moves up. And once I equal to, for a particular angle of incidence, you can see that the deviation is minimum. Here you can see a big deviation. It goes to minimum at a point when the refracted ray moves parallel to the base of the prism. That is known as minimum deviation position, or capital DM, capital D for deviation, M for minimum. So when delta becomes DM, the refracted ray will be parallel to the base of the prism. That's a very important information. And also one more thing, at that time that we will discuss again once again, at that time these two angles will be the same of the rarer medium. Also these two angles of the denser medium will also be the same. All these will be in symmetrical manner. So this I have more or less drawn with DM, means when delta equal to DM. That's a figure representation. This is a usual case. Okay. Then next is just whatever things you have written, it is from the figure only, nothing else. So from the figure, this striped triangle, just look at this triangle. If you want QMR, from that exterior angle is the sum of opposite interior angles. So what is this? I. So what about this again? I, opposite angles. Therefore this much will be I1 minus R1, or I minus R1. You don't have I1, so you can write I minus R1, not I1, I minus R1. Clear? Similarly, what about this? This much E, because this is E. So you need only this much. So what is that? E minus R2. So from this triangle, this is I minus R1 and this is E minus R2. So if you add these two, that will be delta. Exterior angle is the sum of opposite interior angles. So exterior angle delta, sum of opposite interior angles. I know I1, need not take I1, it is I. So I plus E minus R1 and R2 put together. So you have minus of R1 plus R2. Minus taken out, R1 plus R2. Need not put I1. Okay. I plus E minus R1 plus R2. In the quadrilateral, this is the four-sided figure AQNR. Four-sided means 360 degree. But you know that this is 90, this is 90. Angle Q, angle R. They are normals. So at that point, that is 90 plus 90, 180. Finished. So the remaining values are angle A and angle QNR. Both of them together will be 180 degree. Once again, it is a four-sided figure of the two angles 90 plus 90, 180 removed. The remaining two are angle N and angle A and angle N. So they two join to get 180 degree. And also from this triangle QNR, the triangle QNR, you can see that R1 plus R2 plus QNR equal to 180 degree. Triangle means 180 degree. So from these two you can very easily write angle A is nothing but angle R1 plus R2 because these two are the same. Therefore angle A is equal to angle R1 plus R2. One equation. Substitute the value of R1 and R2 here. So what you will get? Instead of R1 and R2 put angle A. So you will get one equation for deviation, the other for angle of the prism. One equation you will get for A, the other one you will get for D. So these two values you are getting. What to say? R1 plus R2. What is deviation? I plus E minus A. I plus E, I1, not I1, I plus E minus angle A. Need not write I1, that is I only. Okay. Right? So you have two equations. Equation 1 and equation 2. Over. Now, you can have a figure to show how I varies with D. When you change I means you are slightly increasing. Initially let it be 20 degree, 30, 40, 50, 60, 70, 80, so on you are increasing. Suppose you vary it from say 20 to 80 degrees or something, you are increasing. At the time what you can see is initially the deviation goes down as I is going on increasing. A particular value of I, nearly 40 to 45 degrees, when it is that, you can say that deviation is minimum. Deviation minimum denoted by capital D small m, showing minimum deviation. After that, when you again increase I, you can see that deviation goes on increasing. So initially decreasing to a minimum, then increasing. This is I delta curve or angle of incidence and deviation curve. Okay, and I told you at DM, when delta, this is delta, when delta has a value DM, this is the point, at the time angle I equal to angle E, at the same time angle R1 equal to angle R2. Both are the same. Therefore, substituting what you will get? You will take A this side, DM plus A will be 2I. So what is I? A plus DM by 2. Similarly, what is R? R will be the same. So A will be 2R. So what is R? A by 2. Then substitute in Snell's law. What is Snell's law? N equal to sin by sin R. Sin I. So what is I? A plus DM by 2. What is R? A by 2. So you have the famous equation, Prism formula, N equal to sin A plus DM by 2 divided by sin A by 2. So if you know the values of A and minimum deviation, how to get the value of minimum deviation? From the graph. How to get the graph? Take different values of I, take different values of delta. For each particular value of I, find the value of delta, plot a graph, then you will get a minimum point where that is known as minimum deviation. So knowing angle of the prism and minimum deviation, you can easily find out the refractive index of the prism with respect to air, means absolute refractive index. So N2 upon N1, that is N21, or simply written as N, because first one is need not say absolutely because it is air. You know absolute refractive index at term. Therefore, this is N21 and N2 with respect to one air. So, need not say nothing. Refractive index of glass will be sin A plus dm by 2 divided by sin A by 2. Hope it is clear. So, just a pause. You can take a screenshot of the board. That is the notes for the topic. Learn thoroughly. Go through the NCERT text. Hope it is clear. If you have any doubts, please put in the comment box. Thank you.